So we had seen how amplitude modulation had been done, how we had seen the frequency of the carrier and the message signal. Now, in this particular video, we'll be talking about the production of amplitude modulated wave. First, initially we had discussed about the amplitude modulation. How did we do the amplitude modulation? By adding the signal. Now let's look at the process. Now if you look at the systematic process, say suppose this is your message. If you're sending a message over here, say suppose you're sending a message over here, let the message signal be AM sine omega mt. So this is the message signal. Now what you do is you send the carrier signal also. This is a carrier signal, that is AC sine omega ct. Now after you mix this two, you have an output, that is x of t. Now you make it pass through the square law device. Square law device. After that, you have a signal yt that is coming out, that is b x of t plus c x of t. So after that, you have a band pass filter center at, now this is a band pass center. This is a band pass. Now we'll slowly and steadily explain everything. Band pass filter. So you just need to know what are the devices it goes through for amplitude modulated wave. So this is your band pass filter center at omega c. This is at omega c. This is for your carrier. Now band pass filter center is operated at angular frequency omega c, and after it passes through this, your amplitude modulated AM wave is produced. So now let's look, this was the physical part, how these two signals are mixed together and then it's let it pass under the square law device, then a band pass filter where it filters, and finally the AM wave it comes out. Here now if you look the modulated signal, if you look at the modulated signal, this can be expressed as, let me use a different color, the modulated signal. This is the modulated signal. So this particular signal can be expressed as, I'm writing this over here, look over here. This is AM, amplitude of the modulated, into sine omega m into t. Now this modulated wave is, or modulated signal, or see what is this? This is AM. AM is your message. AM is your message. So this modulated signal is, this modulating signal is given to your carrier. This particular thing, this signal is given to your carrier. And what is your carrier? Carrier is your AC sine omega ct. So this is what you have to know. Your modulating signal. Now this is not modulated, this is modulating signal. Modulating or modulation signal, or TION. Now this is not completely modulated, so I've rubbed the ET. Now this is the modulating, this is the reason for the modulation. Now this modulating or modulation signal is given to the carrier wave. So in a way we can write WT is actually equal to, is something we don't know. Now WT, we get WT only when these two signal mix together and passes through the square law device. Now let's understand what is the function of the square law device. Now what the square law device does is it adds these two signals, or you can say waves, and the output that the square law device gives is a non-linear device which produces an output, that is the output which is given as WT is actually equal to bx of t. Now this is a non-linear output. You have to keep in mind this is a non-linear output. This is cx square. This is x square into t. This is x square into t. Where b and c are constants, we have to know that this b and this c are constants. So this is what we know. Now let's proceed this calculation further in the next slide. So if we look over here, this y of t after it has passed through the square law device is given by, this is b of x of t plus c of x square of t. So if you put the value of x, and this is x for carrier and for the signal. So if you put this value, what you will have is yt is actually equal to b am sine omega t plus b. Now this is, look, this is c square, so we'll be squaring the whole. This is b a c into sine omega c t plus, this is for b xt, this is for b. Now c, this is c square. Now c square will be given by c. I'm taking the common over here, a square m sine square m t. Now the important thing that you have to know is, after you mix the resultant wave x is given by the sum of, the resultant wave is given by the individual sum of the waves. That is the law of superposition. There is a law of superposition. So this is what we are using. We are using am sine omega mt plus ac sine omega ct. Now when you put x square, you are squaring this. You are squaring this into c. So by this square formula, we have been writing this particular notations. We have been converting this into formula. What is x? X is nothing but your am sine omega t plus ac sine omega t. Therefore, b into x is b, x, multiply this with b, and you will get b am sine omega mt plus b into ac into sine omega c t. So x was actually equal to the sum of the two waves. X is equal to sum of the vector sum of the two waves. Now after passing through the square law device, you have an output of this kind. So therefore we are writing this as the output. Therefore yt is equal to, we have written so far b this, then c, and it is being squared. So plus, let me change the color, a square c sine square omega c t plus 2, that is we are using a plus b whole square formula, which is a square plus b square plus twice ab. So this becomes am into ac sine omega ct into sine omega mt. So this is our complete result. This part, and this part. This is what we get. That is of yt. Now if you further simplify, what you will have is bam sine omega mt plus bac sine omega ct plus cam whole square by 2 plus, now why is this cam square whole square by 2? If you take the common, what you will have, cam whole square by 2 plus ac square minus cam square by 2 into cos of twice omega m into t minus ca square, this is for carrier, by 2 into cos of twice omega c t plus, now this is plus ca m into ac cos of omega c minus omega m into t minus c am into ac into, this is again cos of omega m plus omega c into t. Now, you may get confused as to what we have written over here. Now, what is sine squared? Now, we have used a trigonometric conversion. That trigonometric conversion goes in such a way, say suppose this is sine square a. Now, what is sine square a? Sine square a is nothing but that is equal to 1 minus cos twice a. 1 minus cos twice a, and this is divided by 2. So by using this relation, we have this yt is equal to over here. So now let's move on to our next calculation. So we had our yt, which was finally equal to, if you want to write the yt, that is equal to bam into sine omega m into t plus bac into sine omega c into t plus cam whole square by 2 plus ac whole square minus cam whole square upon 2 into cos of twice m into t minus cac whole square by 2 into cos of twice omega c into t plus cam ac into cos omega c minus omega m into t minus cam ac into cos of omega c plus omega m into t. So this is the final result. Now, there is a DC term. There is a DC term that we have already discussed. What is a DC term? The DC term is your c by 2 into am whole square into ac whole square. And we have sinusoidal frequencies of omega m, 2 omega m, omega c, 2 omega c, and omega c minus omega m and omega c plus omega m. Now, these are the different frequencies that this particular wave has. Now, you can see these are the different frequencies. Therefore, this signal is passed through a band pass filter. Therefore, because it has different frequencies, so it is passed through a band pass filter which rejects DC and the sinusoidal frequencies of. Now, this will reject all the other frequencies. All the other frequencies like this frequency, this frequency, this and this will be rejected. And that is the working or the functioning of the band pass filter. All that will be remain is this omega c minus omega m and omega c plus omega m. So this is how a wave is undergone amplitude modulation.